Have you ever thought about whether we're genuinely alone in the universe, or if there's another component to our reality beyond what we can see? Imagine a scenario in which the James Webb Telescope finally shows that we live inside a black hole. Join us as we explore this urgent news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a terrible dream. You might have seen them in science fiction movies, but in reality, they're not as frightening, according to analysts. Black holes are massive amounts of matter packed into a small region. Imagine a star many times more enormous than the Sun, all squeezed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape. Researchers have been fascinated by black holes for decades because they can alter objects in space so massively and densely that they can trap light. The most notable ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is more than 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is not easy since they emit no light. However, analysts have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. And when a normal star gets too close to a black hole, it can be torn apart, generating X-rays as it does so. Black holes also significantly impact their surroundings. They can consume nearby stars, produce powerful jets of radiation, and even affect the formation of new stars in some regions while halting it in others. But where do black holes come from? Picture this. When beautiful, blazing stars meet their ultimate demise in an epic explosion called a supernova, black holes emerge from the remnants of these fallen giants. Most black holes are born from massive stars that have reached their cosmic retirement party in a supernova explosion. Smaller stars, when they die, turn into neutron stars, which are incredibly dense, but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its gravitational force, forming a black hole. Near their surfaces, something extraordinary happens. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different speed compared to our own. Sometimes, when 2 smaller black holes collide, they merge to form a much larger, more massive black hole. If a black hole interacts with a neutron star, they create a titanic cosmic event that defies observation. Scientists have been grappling with the scale of these massive entities for decades. Black holes come in 2 sizes, giant and small. There's an eerie mystery surrounding them that we just can't unravel. However, here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, the remnants of massive stars, can be as large as 10 to 100 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's a staggering number of black holes that could swallow anything in their path. But wait, there's something else. Supermassive black holes are on the other end of the scale. They're millions, if not billions, of times larger than the Sun, and they exist at the center of massive galaxies, including our own Milky Way. Like a gigantic, dead void, they're pulling everything toward them. Renowned physicist Stephen Hawking discussed black holes throughout his life. His talks were always insightful, though some of his theories couldn't be confirmed due to a lack of essential equipment. However, there's hope on the horizon. A single scientific instrument is making a huge difference, and we're not ready for it. It's called the James Webb Space Telescope, JWST, and it's here to dive into the depths of our universe. The JWST is no ordinary telescope. It's a marvel of engineering and a testament to human ambition. We've launched other space telescopes before, and they've done their jobs well, but this bad boy is unparalleled. The JWST makes the Hubble, which has dutifully served us for decades, seem like a mere piece of space history. The price tag of this technological miracle is a staggering $10 billion. Yes, you heard that right, enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, along with significant contributions from over 300 universities, to bring this marvel to life. But let's not forget the risks that come with such an extraordinary endeavor. This is not a mission for the faint-hearted. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only imagined. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its baseline mission length of 10 years. Since its launch, the JWST has achieved numerous incredible milestones. It traveled more than 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has aligned and calibrated it, the telescope is nearly fully operational. One of the most captivating things about the James Webb Space Telescope was when it was announced that it had captured its first images of starlight. The first picture taken by the telescope was of a star called HD 8446, creating a mosaic of 18 scattered bright spots from the star's light captured by the 18 mirror segments arranged on the primary mirror. NASA later released an improved image of HD 8446, in which 18 unfocused duplicates of the star were combined into a precise hexagonal pattern. When the observatory fine-tunes the individual segments of the primary mirror, it will begin the image stacking process, aligning 18 images into one clear view. Thanks to its advanced technology, the JWST will help scientists explore the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era marks when neutral hydrogen was reionized, or given an electric charge again, by radiation from these first stars. The telescope will also help scientists discover exoplanets, looking back billions which are difficult to detect due to their proximity with a powerful telescope like the JWST. Its strong optics will allow it to see these planets in more detail, including sometimes imaging their atmospheres. Understanding the environments and conditions of planets could help scientists better predict whether specific planets are habitable or not. Besides studying galaxy formation, scientists focus on galaxies to understand how matter is structured on a large scale. This, in turn, allows us to see how the universe evolved. The twisting and warped galaxies we see today grew from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Researchers are also trying to figure out how we got the variety of galaxies visible today in the ebb and flow of cosmic structure and growth. But specifically, the James Webb Space Telescope will help us answer the fundamental questions. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt, and guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking near those supermassive black holes in 3 distinct galaxies. These carbon-based molecules with ring-like structures are like the goths of the universe. They're everywhere, from distant galaxies to comets in our solar system. They're not just interesting because they could be the building blocks of life, but also because they help astronomers trace star formation. When ultraviolet radiation hits these PAHs, they light up and emit infrared light, a frequency that can be detected by the JWST's mid-infrared instruments. This light, captured by JWST, offers crucial insights into star-forming regions around black holes, giving us a better understanding of how stars and planets form in these intense environments. The discovery of PAHs near supermassive black holes suggests that even in these extreme, hostile regions, the basic building blocks of life may exist, raising new questions about the possibilities for life elsewhere in the universe. But the James Webb Space Telescope isn't just stopping at molecules. It's also poised to unravel one of the biggest mysteries in astrophysics: the nature of dark matter and dark energy. Dark matter makes up about 27% of the universe, while dark energy constitutes a staggering 68%, leaving only 5% as ordinary matter, the stuff we can see and touch. Despite making up the majority of the universe, dark matter and dark energy remain some of the most elusive elements, detectable only through their gravitational effects on visible matter. JWST's ability to peer into the deep infrared spectrum allows scientists to observe the effects of dark matter on the formation of galaxies over time. By analyzing the light from ancient, distant galaxies, the telescope can trace how dark matter clumped together to form the gravitational scaffolding of the universe. Understanding these cosmic structures could unlock answers to why the universe is expanding at an accelerating rate, a phenomenon attributed to dark energy. In addition to this, the JWST will also target the cosmic dawn, a period when the first stars ignited and began to illuminate the universe. By capturing light from the earliest stars and galaxies, the telescope aims to provide a clearer picture of how the universe evolved from darkness into the vast cosmic landscape we see today. One of the most exciting aspects of JWST's mission is its search for habitable zones in exoplanetary systems. JWST will be able to study the atmospheres of planets orbiting distant stars, detecting key markers such as water vapor, carbon dioxide, and even potential biosignatures, signs of life. The data could revolutionize our understanding of habitability and help pinpoint which of the thousands of discovered exoplanets might be capable of supporting life as we know it. Moreover, the JWST will examine star systems similar to our own, like TRAPPIST-1, which hosts 7 rocky planets, 3 of which are located in the star's habitable zone where liquid water could exist. By studying the chemical compositions of these planets' atmospheres, scientists hope to assess their potential for life. If successful, JWST's findings could shift the paradigm of where and how we search for extraterrestrial life. While the search for habitable planets and the origins of life is ongoing, JWST will also be instrumental in investigating the physics of black holes themselves. For instance, by observing how material behaves as it spirals into supermassive black holes, the telescope will provide unprecedented detail on how these cosmic giants grow and affect their surroundings. This includes studying the powerful jets that some black holes emit, which can span thousands of light years and influence the formation of stars and galaxies. The telescope's capabilities extend to understanding the life cycle of stars, from their formation in stellar nurseries to their explosive deaths as supernovae. By studying these events in detail, JWST can help us comprehend how elements necessary for life, such as carbon, nitrogen, and oxygen, are created and distributed throughout the cosmos. Ultimately, the James Webb Space Telescope represents a monumental leap forward in our quest to understand the universe. It's not just about observing stars and planets. It's about seeking answers to the deepest questions. Where did we come from? What is our place in the cosmos? And are we truly alone? JWST is already rewriting the story of the universe, and with each discovery, it brings us closer to answers that could redefine our understanding of space, time, and existence itself. As the telescope continues its journey, one thing is clear. The universe is more mysterious, complex, and awe-inspiring than we ever imagined. Whether we find signs of life, unlock the secrets of dark matter, or discover that our universe might be part of something even larger, like a black hole, we stand on the brink of a new era of cosmic discovery. And as the James Webb Space Telescope peers deeper into the unknown, it carries with it the hopes and dreams of generations, daring to ask the questions that have haunted humanity since the dawn of time. Prepare yourself for a future where the universe might not be just vast and empty, but teeming with secrets waiting to be unveiled. The journey has just begun, and the possibilities are as infinite as the stars themselves.